Okay, hi everyone. Today we will be talking about global climate change. The reason why this is very important, especially now, is because the presentations I have done in the past and the ones that I will be doing in the future are all connected to climate change. They all have to do with each other. The climate affects the marine ecosystem, our environment, our daily lives, and so it's important to have a basis of knowledge about this topic so that you can understand the holistic meaning of everything else, since it's all connected. What we will be talking about today is I will introduce to you the climate system. People might think that it's very simple, but it's actually a lot more complicated than it seems. I also want to stress the fact that this is a very simplified, condensed version on what I will be speaking about to make things a lot simpler in order for everyone to understand, just to have a basic knowledge and basic understanding. We will talk about what is normal, what has been happening for the last 4.5 billion years since the Earth came to be, since before humans, since before organisms. And so in order to understand what is happening right now, what will be happening in the future, it is vital to understand how it has been since the beginning of time. And that leads us into what has been changing and what has been causing these changes. Those are things called climate change forcings. There are a few factors that affect how the Earth functions. Something that you'll hear from climate change deniers is that the Earth has been hotter than it is right now. There is no such thing as global warming because it's supposed to be like this. The world has, as I will explain later, different oscillations. You've probably heard of the Ice Age. There has been the complete opposite when the world was entirely water. There was no ice. It was so hot. And that's true, but why is this one different than all the others is something that we will delve into. 97% of scientists say that climate change is a fact. They believe in climate change. 2% are unsure, they're uncertain. They understand that there might be some things that we don't know. And then only 1% say it's not true. So that's something that you should think about. We will also then go into the consequences of climate change, the trends. Climate change has few direct impacts. That's true. However, there are 1,000 indirect impacts, maybe more. So it can get very complicated. So I will go into the direct impacts and just quickly talk about the indirect ones. And then finally, we'll go into the projections and what we think might happen in the next 25 years, the next 30 years, the next 100 years, under certain different situations and scenarios. So the first thing we need to talk about is what is the difference between climate and weather? Climate is the aggregated pattern of weather, meaning the averages, the extremes, the timing, the spatial distribution of whether it's hot and cold, whether it's cloudy or clear, whether it's dry or very wet, or how much snow there is, or natural disasters, weather is now. So what a lot of deniers say, what a lot of politicians is, oh look, it's very cold right now, or Boston just had its record-breaking weather, like winter, where it was extremely cold and it was the most amount of snow that we have seen in human history in Boston. And that's true, but that is in that instance, in that one space of time, whereas climate is the aggregated whole. And that's where we're seeing the change. In order to understand exactly what climate is, you need to understand the climate system. So everything starts in the sun. Everything that the Earth gets, its heat, its radiation, its energy, comes from the sun only. So 100% of what we get hits the Earth. And then only 51% of that radiation, of that heat, is absorbed by the surface. 19% is absorbed by the atmosphere, and then 30% is reflected out. So you can see here a very detailed version. You can read that if you want, but the simplicity of it is all of it hits the earth, some of it is spilled back, some of it is absorbed. And what we want to focus on is the 19% that's absorbed by the atmosphere. That's what we're going to be talking about today. You might have heard of the greenhouse effect, and that is because the atmosphere is 99% nitrogen and oxygen, and only 1% water, carbon dioxide, methane, and nitrous oxide, and a few others. And that is what causes the greenhouse effect. Those are the greenhouse gases. They hold more heat, they hold more radiation, and the Earth is supposed to be about 60 degrees Fahrenheit. Without those gases, without the atmosphere, it would be 0 degrees. None of it would hold into the Earth. And so they're very important. Now I mentioned earlier that there are cycles in the Earth. Throughout millennia, there are glacial and interglacial cycles. That means whether it's very hot or very cold. During the glacial cycles, like the Ice Age, there's a lot of snow, there's a lot of ice. During interglacial cycles, which is what we're in now, it's more warm. And so the external forcings, the things that cause the changes in Earth, are three things. Changes in plate tectonics, Earth's orbit, and the sun's strength, which in more technical terms, volcanoes, Milankovitch cycles, which mean how the Earth spins around the sun, how the Earth wobbles while it spins around the sun, and the axis while the Earth wobbles and spins around the sun. So it can get very complicated, but those cycles last 100,000 years. So they're very long, they're durable, it's how it is. And then there's the sunspots, which is an 11-year cycle. And sunspots is probably what you've heard of before. Every 11 so years, the sun's intensity can increase, so it webs, becomes hotter and colder, not really colder, but more intense and less intense. In volcanoes, they're sporadic. We can't really say whether it's a cycle or not, but when there is a big volcanic eruption, that decreases the Earth's temperature because it causes a cover around the Earth, so the sun can't penetrate the land and heat it up. All those three things affect 5 forces in internal interactions: atmosphere, ice, ocean, the land, and vegetation, plants. And then that can cause change. So you can see here, this is the actual data between glacial and interglacial cycles. The highs are the interglacial cycles, whether it's hot, and the lows are the glacial cycles. So for 500,000 years, you can see that there is a clear trend up and down. And there are some where it can get the global mean temperature to 12 degrees, and the lowest is around 4 degrees. This is including today. So right now we're at 1.5 degrees Celsius average. We should be around 1 degree. And so you can see here that for 800,000 years, it's going pretty well. And then starting at date 0, where we are now, it just goes up. And it's not really going much down. Some scientists, the 3%, say that that might be natural. It might come back down. But we're going to explain why it isn't natural. This is a graph showing natural climatic variability. So if you can see the green graph, that is what should happen. That's the model. The black lines is what you can see. So between 1850 to 2000, 1850 was around the Industrial Revolution, once we started emitting a lot of greenhouse gases into the atmosphere, such as carbon dioxide, methane, carbon fluoride. So we can see here that the green graph, the green line, that shows what should happen. Black is what is actually happening. So these are the greenhouse gas concentrations that have been occurring since the Industrial Revolution. You can see since before 1850, it's pretty low. Carbon dioxide is higher than the rest, but it's steady, it's normal. Then hits Industrial Revolution and it just skyrockets. So this is, we know for sure, from tree rings, coral cores, ice cores. Scientists can look into these organisms that trap those concentrations into their skeletons, into ice cores that we find up in glaciers, and can see the concentrations back in the day. So, Industrial Revolution, world population. If you click into that link, you can find what the current population is right now. I just checked it, and it's 7.6 billion. So, just skyrockets. And as human population increases, so does everyone's carbon footprint. So that is how much carbon we're emitting into the atmosphere. And overall, carbon dioxide concentrations, as of last year, it was 409 parts per million, when the normal is usually right above 250,000 at the maximum. But on average, it's around 225 parts per million. Some scientists say that once we hit 450 parts per million, there is no going back. However, that's unknown. So if you think about what we saw earlier in the graph, where what we're actually seeing versus what should be happening, this is the graph that simulates it with human factors. So this graph here proves that humans are the actual reason of climate change and that we are causing this temperature increase in the world. This is another graph from another source that shows the correlation between temperature, carbon dioxide, and sunspots. This disproves the theory that sunspot is the reason of climate change. Sunspots continues every 11 or so years. However, there is no general increase in sunspot intensity. What is increasing is temperature and carbon dioxide. Those are the clear lines. This is another graph. From now on, until for like 10 more slides, you're going to be only figures. The global temperature. The world is getting hotter. That is a fact. There's not much denying it. There are certain places where it gets cold. However, what we care about is the overall holistic picture. Where's the heat? 93% of the heat is absorbed by oceans. That is because water has a higher heat capacity than air. We know this because we have been learning this during diving. While we're diving and we're in the water, we lose a lot of heat, which is why it's important to cover up. Same reasoning, or same science behind it. The oceans are what are accumulating all the energy. And this is important because they absorb it, they keep it, they hold it, and it's not being repelled back into the universe outside of the atmosphere. And we can also see it through satellite pictures that the oceans are heating up. Sea surface temperatures are increasing, especially around the southern hemisphere. And this will have dire effects on coral reefs, organisms. Eventually, once the ocean is too saturated, it will expel CO2 back out into the atmosphere. And that's going to have a lag time. So there's another thing called ocean lag, where even if we lower our carbon footprint, we stop emissions, the ocean in about 50 years, or in the next 50 to 100 years, I don't remember the exact number, it will start releasing carbon dioxide into the atmosphere, which is all the carbon dioxide that we've been expelling into it. It will come back up to us. Tropical waters are what's going to be the most affected and what are being the most affected. You can see here that the trend from 81 degrees Fahrenheit all the way to 83 degrees Fahrenheit. Some would say that that's not a big jump, but this is average. So 1.5 degrees is a huge difference for small, sensitive organisms. So there are consequences to this. There's ocean acidification, glacier sea ice loss, sea level rise, ocean circulation weakening, algae blooms, habitat loss, species endangerment and extinctions, rise of diseases, and then that's just what's related to the ocean. This is not including all of the social impacts. So ocean acidification. As the ocean absorbs carbon dioxide, that leads to a higher increase in concentration of hydrogen protons, which causes a lower pH. So technically, ocean acidification is a misnomer. The ocean is not acidifying, it's becoming less basic. The ocean should be around 8.3 pH. It's currently like at 8.1. So it's becoming less basic, and that's going to also have dire effects, some serious consequences on corals that use calcium and bicarbonate to create shells and skeletons. And that's going to be in another presentation about ocean acidification. So you can see here, there's another graph. As atmospheric carbon dioxide increases, you can see that purple line, and seawater carbon dioxide concentration increases, seawater pH is decreasing, which scientifically makes sense, but here's the raw data. So this is another impact of ocean acidification. Coral bleaching, there's less coral covering the ocean floor, and thus we're losing habitats. We're losing dire, highly productive spaces in the ocean that provide all of the support and foundation for 1,000 other species of fish and organisms and other plants. As well as the fact that ocean acidification not only decreases the amount of coral coverage, but it makes the coral weaker. Another impact is sea level rising. Because it's getting hotter, sea ice and glaciers are melting, causing sea levels to rise. This will be important infrastructurally in the fact that we're going to lose land that is currently with people. You can see a picture here of the amount of glacier we have lost in the North Pole. That's insane. Like, it is a big deal, the fact that this is happening. All of this ice is more habitat for many species like polar bears. That's like almost half reduction. Glaciers are being lost. This is our source of fresh water. So this is all going to lead to more indirect effects to society. And due to the fact that glaciers are weakening, due to the fact that glaciers are decreasing, they're melting, that's also affecting the global conveyor belt. So to simplify things, the Earth has certain currents in the ocean. And these currents are affected by the Earth's rotation and temperature. So as hot water rises and cold water falls, that causes circulation in the ocean. With temperature increasing, what's happening is the cold water that's supposed to be up north is getting warmer, and so it's not falling as it should be. And so that's slowing things down, and it's preventing circulation to occur as it should. Eventually, if this keeps on heating up, it's possible that it will stop entirely, meaning no more currents as they are right now. Then the consequences on land. There's extreme weather. So what I was saying at the very beginning of the presentation, where it's not about weather, it's about climate, that is because just because one place in the US is having amounts of downpour, another isn't. Another is having a drought. So this extreme weather is one of the effects of climate change. And that will also cause more social impacts. There's hotter years, so there's more fires. You can see in the graph here, it makes sense. In California this year, last year, there has been more fires, more often, bigger, and harder to control. There's more rain. There's an almost 10% increase. You can see here a picture, a map of the US. Those dark spots are the amount of percentages. So the darkest spot, that's a 200% increase, twice the amount of rain as usual. And the fact that it's more rain does not mean like, oh good, it's great, climate change isn't bad, we're getting more rain, that means more vegetation. It's actually quite the opposite, because that's causing more runoff. It's so much rain that it clears land. And there's some areas that are getting even less rain than usual. There's bigger tornado outbreaks. Whoever lives in the Midwest, there's more tornadoes, more hurricanes, more cyclones, stronger cyclones, more droughts. You can see all of these graphs. It's slower if I'm going too fast, but it's there. And then there's all the possible impacts of climate change on the social effects. So this is just one graph or one figure that I found. The IPCC has very well laid out all of the possible effects that we can see and that we are currently seeing. There's diseases that's caused by, so there's some bacteria that have been trapped in the ice for thousands of years, millions of years, from all these ice ages, and they've just been piling up as ice piles up. As the Earth is heating and those glaciers are melting, that's releasing those bacteria or those mosquitoes or all of that into our atmospheres where we will have contact with them. So there's going to be more diseases because of this, as well as the fact that it's hotter and there's less fresh water, and that's going to cause more diseases to arise due to the higher overpopulation. Eventually, or basically, climate change is going to affect poorer third world countries, poorer communities. Climate change does not affect everyone equally. It's going to affect us all, but some people are going to be affected more than others, and I think that's extremely important to understand and admit. This is another graph where it just shows the amount of the vegetation in the area is going to play out differently than usual. Some plants are moving up higher latitudes because they need a certain amount of temperature in order to thrive. Some plants are spawning earlier or later. Everything is changing in vegetation, and that's going to affect farmers. It's going to affect societies that depend on these vegetations. It's going to affect industry, trade, economies. So it's one direct effect has 1,000 indirect effects, and that's something that we need to understand. So socioeconomic impacts, as I said, agriculture, fishing, food security, jobs, tourism, salary, costs, health, and there's inequalities. You can see here all of the effects that are indirect.